Welcome to Math Refresh. In Math Refresh videos, we intend to refresh our rusty memory of some basic mathematical concepts, which we have learned years ago. Hope it doesn't bring back bad memories that some might have of a moody, grumpy teacher. Rather, it brings back good memories of sitting behind a desk, learning enthusiastically with fun classmates and teachers. So we start our lessons by focusing on some basic concepts which you would find under the category of pre-algebra. Then we take it from there to the next level, which would be algebra lessons. So that means the first stop would be pre-algebra. Let's start with the concept of place value. Place value is the base for our entire number system. It means that the position of a digit in a set of numbers defines its value. The standard system is called base 10, using only 10 symbols called digits, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's say we have a number 4. What value does it have? It has 4, meaning that we have 4 items of something, 4 apples, or 4 books, or 4 hats. We write the number 4 under the name of units, or ones. Let me put the number down for you to see. But what if we have more than 9 items? But what if we have more than 9 items? Let's say we have 14 items. What do we do now? When we have more than 9 items, we start another column, the tens column, and we write down how many tens we have, followed by how many ones. Let me draw the table here so you can see. So we know that we have 1 10 and 4 ones, which makes 14. This could also be written as 1 times 10 plus 4 times 1. Now, what if we have more than 99 items? Then we start another column, the hundreds column. The table will have 3 columns now, which would be hundreds, tens, and units. Let's continue our previous table. Imagine a column of 200 spheres. We can't draw 200 spheres, so just imagine them there with these lines. We know we have 2 hundreds, 1 10, 4 ones. This could also be written as 2 times 100 plus 1 times 10 plus 4 times 1 equaling 214. So each time we need to show a bigger number, we just add 1 column to the left. And we always know it's, So each time we show a bigger number, we just add 1 column to the left. And we know it is always 10 times bigger than the column on its right. Each new column on the left is 10 times bigger. Therefore, we place a digit. Therefore, where we place a digit is important. The column will continue in this way as the number gets bigger and bigger. Remember, numbers are arranged into groups of 3 places called periods: ones, thousands, millions, and so on. Places within the periods repeat: hundreds, tens, ones. Commas are used to separate the periods. Let's review each name through an example. Let me clear the screen so I can draw the table. Ones column. Thousands column. Millions column. Units. Tens. Hundreds. Thousands. Ten thousands. Hundred thousands. Millions. Ten millions. Hundred millions. Two units. 0 tens. 1 hundreds. 4 thousands. 2. 5. 3. 8. 0. Let's add one more column to show that the trend continues. The number 2 under billions. How do we read it? How do we read it? It reads 2,083,524,102. I'm going to put some numbers here for you to practice place value. Let's imagine we're in a classroom. Here's a little pop quiz for you to practice place value. Identify the value of 5. Identify the value of 5. Let's clear the board. Now that we reviewed the concept of place value, we can focus on decimal. As we discussed, when we write numbers, the position or place of each number is important. In the number 825, the 5 is in the units position, meaning just 5, or 5 ones. The 2 is in the tens position, meaning 2 tens, or 20. And the 8 is in the hundreds position, meaning 8 hundreds. 825. As you have noticed, as we move left, each position is 10 times bigger, from units to tens to hundreds. As we move right, each position is 10 times smaller, from hundreds to tens. But what if we continue going to the right until we pass units? What is 10 times smaller than units? It means whatever number it is, it has to be divided because it's getting smaller than 1. That's why we use division. But first we must write a decimal point so we know exactly where the unit's position is. Then we write the smaller number. What is a decimal point? The decimal point is the most important part of a decimal number. The word decimal really means based on 10. From Latin decima, a 10th part. A decimal number usually means there is a decimal point. Decimal point is exactly to the right of the unit's position. Without it, we would be lost and not know what each position meant. In fact, the decimal point signifies and, in the sense of plus. Here's an example. 158.45. The decimal point separates the whole number from the smaller number, which is smaller than 1. So our decimal system lets us write numbers as large or as small as we want by using the decimal point. For instance, 267.983. The number to the left of the decimal point, 267, is a whole number. As we move further left, every number place gets 10 times bigger. The first digit on the right means tenths, 9 tenths. As we move further right, every number place gets 10 times smaller. How do we go about creating a decimal? First, we will divide 1 into 10 equal parts, and so each part is called a tenth. If we divide each tenth into 10 equal parts, then we will be in 100 equal parts. And so we have divided 1 into hundredths, and so on. Those tenths, hundredths, thousandths are called the decimal units. Let's work with an example. Let's say we have a number
12.3875069. How do we read it, and what does it signify? The digit at the first decimal place shows the number of tenths. In the number above, there are 3 tenths. The second decimal place shows the number of hundredths. In that number, there are 8 hundredths. 7 thousandths. 5 10,000ths. 0 100,000ths. 6 millionths. 9 10,000,000ths. 10. We could think of a decimal number as a decimal fraction. A decimal fraction is a fraction where the denominator, the bottom number, is a number such as 10, 100, 1,000, etc. Here's an example. 4.3 would look like this. Or 23.26 would look like this. However, you will hardly ever see a decimal written like this. Here are some examples for you to work on your own. Let's clear the board again. Let's do a little homework. Rewrite each number and eliminate the unnecessary zeros. Zeros on the right of a decimal or on the left of a whole number do not add anything to the value. 3.72000. 00.08. 6.000. 0406.00030. 0.007. 007. Rewrite each of the following with 3 decimal digits. Do not change the value. 12, 0.5, 3.12000. This is pretty much what is important about decimals. Now we can move to the next subjects, which are going to be fractions, percent, ratio, and proportion.